All right, sweet. Go ahead and get the presentation ready. Can everybody see my screen?
Sure.
Yep.
Yeah. Sweet. All right, welcome everybody. This is our first actual general meeting during the school year. So this is where the fun begins. We got a quick agenda for you guys, nothing crazy. The handbook is out, first things first. So like I said, if you haven't already, go ahead, take a look at it, download it. It's gonna be our main resource for the entire year. You're gonna need just about everything for the competition is in there. Anything else that's left out is standard stuff that's in their Q&As. But we're going after the handbook, we're gonna go over the general proposal review. So all the requirements for the proposal, stuff to keep in mind as you're going through your research and designing. After that, just some quick sub-team tasks from your team leads, and then some closing statements to finish it off. Like I said, handbook's out. It's a picture of it right there. There's a link here in the presentation. There's a link I posted in the Discord. Please, I urge everyone to read your section. Your section relevant to your team is a required read. And then also along with what's required in the proposal, because we will have to submit that to NASA. So your team will be responsible for writing your own section. The systems team and I will be stitching everyone's sections together to make sure everything's coherent. But everyone on their own sub-team is responsible for their section and their requirements. So please read it. It's not that long of a read. It document says to 120 something pages, but the NASA student launch competition is like the first 50 pages. The rest is the design competition and other things. So after this, we have the proposal. Okay, Alex.
Oh, sorry, I was still muted. Guys, the proposal is due in exactly 1 month. I know that seems like a long time, but it's really not for the amount of stuff that we have to do. There's a lot of things that go into this proposal. These are like the 6 main divisions of the proposal that we need to work on. General information, pretty easy. It's just the names of the school, address, name of Edberg and our mentor Rick, along with with our team lead, things like that. Then next up, we have facilities and equipment. I don't think this is going to change much from last year's. Maybe now that we can meet in person, we can add the structures lab or any other lab that we get access to, things like that. Safety, there's a lot of things for safety. I know I only wrote safety plan, but there is maybe, there's an A through G for safety. There's a lot of things. NASA really wants us to make sure that nobody's going to get injured or anything like that. And we need to provide plans for like everything, for hazard recognition and accident avoidance. All these things need to get done for safety. Next up, technical design. This is like the meat and potatoes of everything. This is where all our numbers and calculations are going to go. We need to include the general dimensions. It doesn't have to be exact. They know that we're most likely going to change up our design, but they just want general dimensions, preliminary material selections, and justification for that. Construction methods, are we going to make our own? Are we going to buy it? We need to include our projected altitude and show them how it was calculated. We need to include our planned recovery system design, our projected motor brand and designation, what class of motor, detailed descriptions of the team's projected payload. They want to know what we're gonna pick for our payload. We gotta address the general, all the requirements that are on page 17 to 14 of the handbook. We have to address all of these requirements in our proposal and address any major challenges and solutions that we have to these challenges. Next up is the STEM engagement. We need to show them that we have a plan to reach all these students and how we're going to evaluate our STEM engagement activities. Next up is the project plan. So this is where we have a schedule or a timeline with a WBS covering all aspects that are necessary to complete this project successfully. We also need to give them a detailed budget, including travel costs for Alabama. We need to show them that we are gonna have funding, either through GoFundMe, through crowdsourcing, or sponsors. We got to let them know of those. And we also have to show them that our rocket is sustainable, like how to provide and maintain partnerships and regularly engage successive classes of student in rocketry. Like, I'm not sure what that really means, but they just want us, they want the rocket to be reusable, definitely.
Yeah, so for that, they just basically mean that whenever we're doing our STEM activities, we are going to be incorporating rocketry and letting them know that it is not a dying hobby or a dying field, just to increase activity for future generations. It's part of the outreach program.
Yep.
We'll talk about a little more later.
And next up, we have Payload.
All right, guys. So I'll be going over some of the key requirements for Payload. So these are the most important ones that I've identified and pulled from the payload requirements in the handbook. And that would be: the payload shall be capable of autonomously locating the launch vehicle on a gridded aerial image. So there are a couple of options that we have there for that. GPS cannot be used to aid in any part of the payload mission. Unmanned aircraft, very important. They have to abide by all FAA regulations. And if the payload is an unmanned aircraft and it is greater than 0.55 pounds, it needs to be registered with the FAA and have the registration marked on the vehicle. Some areas of research that we need to be jumping into today for the proposal would be the vehicle type, ground vehicle, or UA, or an unmanned aerial system. We need to look into methods for locating the launch vehicle. Possible ones could be image recognition, IR sensing. Those seem very difficult. I'm open to suggestions. And then we need to get into some of the top level vehicle characteristics. On the right, I have an image from the software that I put into Payload chat last night. This would be Mission Planner, which was used like 3 years ago in our mission when we did a drone that needed to drop off a payload in a specified location for them. And it was relatively easy to get it working autonomously. So we can look into using this for controlling it if we go, or just controlling either vehicle.
Sweet. Now we're moving on to payload integration.
Yeah, so for everybody in payload integration, just there are a lot of our requirements are kind of going to be shaped around whatever it is that payload decides to do. But for the most part, the ones that come from the handbook that are pretty important that you should remember. We're not allowed to use any black powder energetics for payload deployment. Any pressure vessels that we do use have to be compliant with the specifications that they laid out in the manual, which there are too many and they're too boring to list out here. But in general, last semester we used a pressure vessel and it didn't exactly go the greatest. So that's a route that we're maybe thinking about not going down this year. But if that's a suggestion that you guys have, I'm more than willing to talk about it. If we do use any lithium ion batteries, they have to be protected and also brightly labeled. A new one is that if payload does decide to use a UAS, that has to be tethered to the rocket with a remote controlled retention mechanism. So that'll most likely be a responsibility that falls on PLI to integrate. Also, the rocket itself has a maximum of 4 individual sections, which isn't that big of a responsibility on us, but I know last semester we ended up using the nose cone as one of our detachable sections to release the PLI. A couple areas to start researching. So we definitely want to start brainstorming ways to actually hold the payload, like the retention system for whatever it is we decide to hold the payload with, as well as ejecting it. And usually that entire thing is done through like the computer system we use involves altimeter sensors, maybe some velocity sensors or accelerometers. You can kind of see off to the right was last year's design, where we basically had the payload being ejected with like a burst of CO2. And it was, can't really see it in the picture, but it was being retained by like linear actuators that would kind of lock into some slots. So that was the design we used last year. You just brainstorm some new ideas that maybe we can implement this time. And also just the actual microcontrollers we can use. I mean, our main options are like a Raspberry Pi versus an Arduino. Both have their kind of pros and cons for piloting this type of system, but just starting to consider what we should use for that as well. And that's about everything.
Yeah, sweet. I'm really excited to see what you and Payload come up with this year.
Yeah, me too.
Should be interesting.
I hope
Moving
so.
on to structures. Josh?
So these are some of the key requirements for structures. As you can see, there's a lot, and there's actually more listed. So please go over the handbook to see what's applicable to us. But the launch vehicle has to be recoverable and reusable. It has to have a maximum of 4 independent sections. It has to be capable of being built and be able to fly within 2 hours. And it's limited to a single stage, meaning there's only one motor. And here are some requirements for the pressure vessel. Yeah. And it has to have a thrust to weight ratio of 5:1, and the structural perturbance on the rocket will be located aft of the burnout center of gravity. There's a lot. And on top of that, if we want to be more ambitious this year, we need to do research on air brakes. And we are, as they said before, we are limited to 3 flaps. So some of these pictures aren't very applicable, but we should figure out like if we needed the placement of the flaps, if forward facing is better or backward facing or just straight out. And yeah, that's a.
Yeah. Anything else for structures related? You can go ahead and ask Josh or Garrett, but these are some of the requirements. Some of the ones not listed there. It has to have a rail exit stability of 2.0 and leaving the rail, but that's stuff that we're going to worry about later on. Just know that the analysis team, the structures team have a lot of requirements. So it is definitely required for you to read through the requirements. They have easily the most restrictions and rules placed upon them. So do your due diligence and read the handbook.
If I can interrupt also, just one more thing. While we're still early on inside of the design process and we're getting weight estimates for each of the subsections, just try to be as detailed as possible, anticipate any sort of, I don't know, extra structural support that you may need or the actual weight of some of the material that you're using inside of your design. Because the more accurate you can be now, the easier it'll be for us on launch vehicle in order to actually hit our target apogee that we're going for. Because the further on that we make these sorts of adjustments, the lot harder it is to compensate for, basically. So, but that's just all I wanted to say for now.
Yeah, we did run into that
piggyback off of what Garrett said, because last year that happened to us where I didn't give updated weight measurements to Garrett, and it really screwed us over the night before a report was due. So like, if you guys make any updates, don't forget to let structures know, please, or analysis, sorry.
Yeah, so I just want you to know that. No hard feelings.
Yes.
I love it.
Yeah, man, no,
Yeah.
I understand.
Sweet. Moving on to analysis. We got Boomy.
Yo, what's up? Can you guys hear me?
Yeah.
Okay, great. Yeah, the key requirements right here is to meet the altitude of apogee to 4,000 to 6,000 feet, and that is driven by the weight that Garrett mentioned earlier. Launch vehicle design, recoverable and reusable, which is going to drive our material choice. We want to have a harder enough material, so if it does end up hitting the ground a little too hard, we can reuse it. Have a static margin a static stability margin of 2.0 at the rail exit that Nathan mentioned earlier. A thrust to weight ratio of 5:1. Total impulse of the launch vehicle will not exceed 5,120 Newton seconds, and that drives the motor class. I think no past than L class. Correct me if I'm wrong, Garrett.
Yeah. L class.
Yeah.
That's correct.
Okay. And minimum velocity exit at 52 feet per second at rail exit. And to meet these requirements, I would need to get Open Rocket and Rocket Sim to my team real soon.
Yeah, we're working on that.
Yeah, for sure. And these are the key requirements. And like Nathan said, there was a lot more to list off, but I think these are ones that analysis should hold as like key stuff. areas of research, I would like to have you guys dig into material choices, which are most feasible, that can retain all the sections throughout the launch. Last year we used, was it fiberglass, right?
Yeah, we used G12 fiberglass last year.
G12 fiberglass, yeah, and that's still an option, but I would like for my team to look for other options. I've heard carbon fiber might be a possibility, or other forms of fiberglass, I believe. I believe, was it Garrett, you didn't want us to use blue tube? Is that the
Yeah,
Yeah.
blue tube is
No phenolic paper and no Bluetooth, which
No
they're basically the same thing. Just so that basically that whole reusable part, you won't be able to achieve that with Bluetooth because Bluetooth is really sensitive. And if you don't, I guess, launch and stage perfectly, then it's going to tear itself apart.
Yes.
Yeah.
So we definitely don't want that happening. I'm sure if it falls apart, it will drive our cost up drastically, which we don't want. I would like for us to look into ways of to have the rocket very stable, and because wind was a problem for us last year, and I think we ran into like 20-mile-per-hour winds, and that chewed our apogee height. And we would like to, me and Garrett talked about finding ways to keep this the rocket as straight as possible, even with strong winds occurring. And so I think canards are like what you see here in the image on the right, which are like these fins towards the tip of the rockets. Those are the canards. That's a possibility to make it stable, but I would like for us to look for other options as well. And
Boomy, I just wanted to remind you that for recovery, you might, like if you go with the carbon fiber build, you might need one section that's not carbon fiber so that it's transparent to RF waves, right?
yes.
I had one question, or at least a proposal that maybe recovery could be open to. The one idea that we had is using a carbon fiber body, theoretically, if we went with something like that, but a fiberglass cone. So that way the AV bay could be inside the cone, for instance, and you basically, you just have to remove the sled rather than removing the whole AV bay, would kind of just be a concept, but that's again, just an idea for recovery. It's not necessarily something that has to happen.
No, yeah, definitely. We will talk about that more when we get a little more, after everybody's done a little more research and they're more dead set on what they want to do. We'll talk about placements and material selection as well. This is just, ideas that we're putting out right now so everybody can start researching and hit the ground running.
Yes, yeah, and that's all for me. So I think next is was it Avionics, right?
Avionics.
Yep.
Hello, everyone. So the handbook does have quite a lot of requirements for the vehicle, but these are the most important that are related to the avionics section. So it states that we have to have 2 barometric altimeters and they have to be commercially available. So from like the examples are the pictures I have above, like the Missile Works, featherweight altimeters, egg timer, and perfect flight. Those are examples of the ones that we can look at and decide upon. And next is a dedicated mechanical arming switch. Usually it's just something that has like a key to arm the altimeters. And that's important because you don't want to arm it before you set the rocket on the rail. So usually it's available externally. And next is the GPS. So we need to have active tracking on the device, of course, and on the rocket. And the next one is the recovery electronics need to be shielded from other transmitting devices. We will have to see if any of the devices from perhaps payload would interfere with ours and such, but that's something to consider when we're designing. And the next one is the apogee event. Cannot have a delay more than 2 seconds. So when it reaches the peak, the velocity will become 0, and we have 2 seconds to deploy the drogue parachute from that point. And next, the parachutes have to be deployed no lower than 500 feet, which we need to program our altimeters above that. The main should be well above 500, perhaps 600 or higher, and then the backup would have to be at least 500 or higher. And next, for the research areas, we need to start looking at which altimeters, the GPS systems we're going to use. The brands I have mentioned are listed below. The Missile Works and etc. They do have a lot of different models. Those are just a few of the pictures that I threw up there, but each company makes like 2 to 5 models of their altimeters and such. And then we need to just start getting some ideas for the avionics bay, where it's going to be located, how it's going to be easily accessible, and we need to start doing some CAD drawings, or diagrams, excuse me. And finally, we need to figure out a way to prevent the electromagnetic interference, or EMI. That's a key research area, because we don't want it to go off prematurely and during flight, or too late perhaps. And yeah, now I'll be passing it to the parachute section.
Before I pass it on, we ran into that issue last year, and I know the last year's avionics team used some copper tape to mitigate interference. So you can, anybody on the avionics team, go ahead and talk to Alex or Yosef. They'll be gladly to help you with any questions, recommendations for anything on the avionics team.
Right, sounds good.
Yep. So we have parachutes with Ashley.
Yeah, so for parachutes, after reading the handbook, some of our key requirements are that we have 2 parachutes. The drogue parachute is going to be deployed at apogee, and our main parachute is going to be deployed at a lower altitude, which is no less than 500 feet. And our apogee event has to have a delay of no more than 2 seconds. For both parachute compartments, we're going to need removable shear pins. And for our deployment, we are not allowed to use motor ejection. And for our descent time of the launch vehicle, we're going to be limited to 90 seconds or a minute and a half. And that ranges from when our rocket reaches apogee to when it touches down. And for our areas of research, we're going to have to research various packing methods and potential ejection methods, as well as how to calculate descent time and the needed parachute size in order to meet our requirements. And I'll be passing it on to Anthony.
Hey guys, so for our proposal, we got to do for systems, our facilities and equipment, they need, oh, there's an extra slash in there, my bad. They, oh no, there's not, sorry. So what we need for our equipment and facilities, and also the descriptions of those facilities and equipment, we need to go over safety, risk cube, safety plan, safety acknowledgement form. There's some more stuff to add to that. We have our project plan. We have to make a work breakdown structure, a Gantt chart. So we have to do both of those. And then we also have to really start thinking about our funding plan, right? So possible sponsors, current sponsors, and then our budget. So we're gonna have to keep tabs on Dr. Bandari. I know we had a possible sponsor from Northrop, but we'll see how that goes. We got to come up with a presentation and everything for them. But that'd be great. And then to do in the near future, we are gonna have to, not until we really get the proposal done, verification matrix, pretty much going through all the requirements the handbook lays out, and then putting it into a table or a matrix. And that way we can always reference it back to make sure we're fulfilling the requirements, right, as we go through the project. And we also need to go over the system requirements, which are the ones NASA gives us. And then we need to derive our own requirements from that. So we'll always have to, especially the liaisons, we'll have to meet with our teams and especially derive our requirements according to their needs and the needs of the handbook.
Sweet. And then now it's just closing statements. Team hour logs have been done and they are uploaded on the drive under team info. NASA requires us to keep an hour log of the hours worked on the project. So everyone on the team is required to fill those out. I will be constantly pestering you guys, reminding you guys to fill them out because it's really easy to forget. It takes like 5 minutes to do, but it's really easy to put off. Please don't put it off because it's a requirement at every stage of the project to let them know how many hours you've put into work on the project. This also goes for senior project credit students. There's a separate sheet dedicated for hours for Dr. Edberg that he will be taking a look at. And if that's not filled out, then there will be some trouble. Once again, team bios and pics, please get them in by tomorrow so we can update the website. And then lastly, do your research for your sub teams. As you can see, there's a lot of work to be done. It's pretty exciting. If you need help getting started, don't be afraid to ask questions. Shoot a message. Discord is always available. Me and Alex are pretty much available 24/7 to reply back to messages. Trust me, we'll be awake at times. At times you think we won't be awake. As for outreach, Angela, me and you and Alex can set up a meeting day to start working on the outreach program. Start getting some preliminary ideas down on the paper, talk about what we want to do. There's different methods for outreach that are talked about in the handbook. And then for senior project credit, add codes. Please add the class so I can stop worrying about you guys having or have not added the class. About half of you have already have. And then for my ME students, I'll be going to campus on Monday to ask some questions to try to get some clarification on adding NSL as senior project credit, because I know you guys have been having to jump through some hoops, which has been quite annoying and quite stressful for all of us involved. But yeah, that pretty much concludes the meeting. I'm gonna go ahead and stop recording. But yeah, that's pretty much it, guys. Meeting's over. If you have any questions, any comments, concerns, you can go ahead and ask them. Other than that, we're good.
Thanks, guys. Have a good weekend.
Yep.
All right, later.
Cool. Hey,
Later.
Payload, you guys want to hop into the Payload comms and Discord for a little bit, talk about this?
Yeah, sure.
Cool.
Sure thing.
Sweet. And then yeah, that's pretty much it. If you guys have any questions, feel free to reach out.
Yup.
Hey, Nathan,
Nope.
I did have one
What's up,
question
man?
actually. Hey,
No, you can't ask questions. No, I'm just kidding.
no.
Just kidding. What's up?
So for the team log hours, is that only for seniors, senior project, or is that for everyone?
No, that is for everyone. So NASA
Okay.
requires that we have a hour log of all of the team members and what they've done and how many hours they put in. And so we can give them a total number of hours that the team has put in for the project.
Okay.
They do this just for the record. It's required at every stage. So when we turn in the proposal, we do PDR, CDR, FRR, et cetera, et cetera. Yeah. So there's
Okay.
2 hour logs. If
Yeah.
you're not claiming senior project credit, you only need to fill out the one that says team hour log. The other one that says SP hour log or senior project credit hour log, you don't need to fill out.
Oh, gotcha. All right. Thank
Yeah.
you. Yeah.
Yeah, no problem. I'll post a clarification about that in the Discord.
All right.
Sweet.
All right.
Yep.
Thank you, guys. I'll see you later.
Yep. Later.
Nathan,
Yeah, what's up?
before you start getting committed to like doing a presentation for, for the sponsorship, let me